Hi guys, Michael Grogan here, and this video tutorial will be focusing on neural networks and how to generate them in R. Neural networks are one of the more popular machine learning tools that we have at our disposal. So basically we're going to be taking a series of inputs and we're going to be coming up with outputs based on both the input attributes of the data and also certain hidden attributes in our data as well, called hidden neurons. So to illustrate how this all works, we're going to be using the WINES data set from the UCI machine learning repository. So let's go ahead and load that up. And basically what we have is we have groups of wines, and we've numbered them 1, 2, and 3 here, and then we have various attributes of those wines, so alcohol, malic, ash alkalinity, etc. And what we're basically going to be doing is we're going to be using a neural network model to classify wines into specific groups based on their attributes. So alcohol, malic, ash, all these independent variables will be our inputs into the neural network. Then we'll have various hidden nodes which will pick up variation that aren't picked up by our input nodes, and then we're going to come up with an output generated by the neural network model to be able to classify these wine groups. So when we run a neural network model, the first thing we want to do is we want to make sure that there are two things we want to do. One, we want to make sure that we're normalizing our data effectively in order to actually make sure that our results are to a common scale, our variables are to a common scale, so we can compare them accurately. And what we also want to do is we want to actually test the model to see, does it actually run properly using training and test data, so cross-validation essentially. So when we run the max-min-df function, and all this is basically a max-min normalization technique. So you can see that we've scaled the data, so we can see that it's between 0 and 1, and using this scale, this is the scale upon which we're going to be comparing our data. And we're going to be using an 80 we're going to be using a split between our training and test data. So you can see that the first 142 observations are our training data, and then up to 178 is the test data. And the reason we do this is because we're going to use the training data to actually build the model, and then we're going to be using our test data to validate our results that we're getting from the model. So we want to see how accurate is our model in predicting the classification of the wines. So when we've run those, what we're going to do is we're going to build our model using the neural network. So we have the neural net library loaded in for that. And you can see that our neural network is taking the winery as our dependent variable. So the wine groups is a dependent variable. And like I mentioned, all of the independent variables are the attributes of that wine. We're using a 2-1 hidden configuration. Our linear output is set to false and our threshold is at 0.01. So we're going to go ahead and generate this neural network. I'm just going to make this plot bigger for you to see. Okay, so now that's in focus. And so you can see that on the left hand side we have our input neurons. So this is where all the inputs are being fed into the network. We have a 2-1 configuration, so 2 hidden neurons followed by 1 hidden neuron. And as I mentioned, this is picking up all the variation in our data that is not being picked up by the input neurons themselves. So what the neural network is doing is it's using back propagation to be able to actually train the model for accuracy, so that when we get the output that we're coming up with an accurate classification essentially. So once we've generated the neural network, what we want to do is we want to actually test the output that we're getting. So you can see that our test data here, this is the data that we're actually using to validate against the results that we're getting from the neural network. So the way that we are actually going to test for the accuracy of our neural network is using what's called a confusion matrix. So a confusion matrix will allow us to see how accurate our model is actually predicting in terms of classification. So you can see that our prediction variable is set to the results that we're getting from the neural network, and the actual results are from the test data set. And now when we run this, you can see that we have 16 true negatives, 10 true positives, and 10 false positives. So you can see that 16 of our classifications were predicted to be 0, and they actually were 0. 10 were predicted to be positive, and they actually were positive. On the other hand, 10 were predicted to be positive, and they actually came in negative. So 26 out of 36 classifications, that's a 72% accuracy rate. Now, we could potentially get that accuracy rate higher by modifying the number of hidden neurons in our neural network, or by gathering more data for this, but 72% given 178 data points or 142 data points in our training set, that seems to be reasonable enough based on the number of data points we had. It's likely that if we had more data points, our neural network would be better trained, and we might see more accurate results coming in from our confusion matrix. But one particular way of playing around with the accuracy, as I mentioned, is modifying the number of hidden neurons. So we have a 2-1 configuration here. We could just as easily modify this, so we could set, for example, one other time I ran this model, I set a 5-5 hidden neuron configuration, and we actually came up with a 78% accuracy. So one way of, as I mentioned, coming up with better accuracy rates potentially could be through modifying the hidden neurons. But generally, all of this code is available on my website. This is more of a brief introduction to neural networks and how they work. But feel free to download the Wine dataset from the UCI machine learning repository, and this code is available on my website for you to simulate the neural network yourself and practice it essentially. So many thanks for watching, and feel free to reach out if you have any questions on this. Thanks, guys.